cement industry. And I welcome the session chairman for this session, Mr. PVR Murthy, Head CM Holcim India. Over to you, sir, for conducting this session.
Good morning, good afternoon, CII. Good afternoon, all participants. Welcome to CII event. This is a very important event and a very unique event that is happening in this year towards decarbonization. I'm PVR Murthy. I'm head SEM Asia, serving Ambuja and ACC groups, as well as Philippines and Bangladesh, Australia and New Zealand, from Thane office in Mumbai. And I'm a chemical engineer by profession and worked in Cement Research Institute for 8 years, later into Simco Birla for 6 years, and PhD Humboldt for about 20 to 25 years. Decarbonization, I think we are all aware, is today the buzzword and the word of today. Of India or the world are focusing towards sustainability, focusing towards CO2, focusing towards technologies, focusing towards heat consumption, focusing towards consumption. Focusing fuels and alternate fuels.
Is everybody able to hear Mr. Murthy?
No, sir. No. No.
Murthy, sir, we are not able to hear you.
Viber?
Yes, sir. There was, I think, some audio problem from your side, sir. We couldn't hear you. Now you're audible, sir.
Okay. Shall we start the session?
Yes, sir. Yes, sir.
Yeah. Dear all, welcome delegates to CII 2022. CII is a platform with all employees of CII. The technological changes, the technological body of Indian cement industry or global cement industry are working in that direction. I'm PVR Murthy. I'm head SEM Asia, Holcim, connected to Ambuja group of plants, ACC group of plants, Philippines group of plants, Bangladesh plant, and Australia and New Zealand. We every day talk about only one word, that is CO2. We start the day with CO2, we end the day with CO2. Once we start our day with CO2, it becomes a hobby for us. It becomes a passion for us. It becomes a kind of grilling sessions, subjects every day that go in our daily life. We often do grill sessions, grill down ourselves into the CO2 in every plant, in every grinding station, in every pyro. Today, the technology is very good level, and today our presentations are going to focus on the achievements at which the case can be carried. All CO2 capture, or whether and I start with Mr. Sundar Raj. Now you are able to hear? Hello?
Yes, sir. Yes, sir.
Yeah. Mr. Sundar Raj, the first presenter. Yeah. Sundar Raj, are you there?
Yes, sir. Thank you, Chairman. Thank you, Murthy, sir.
Wait 1 minute, 1 minute. Yeah. Sundar Raj, you give your introduction, okay? And you limit timing of the paper presentation with the given time, and give the platform for question and answers. Yeah, over to you. Yeah, Sundaraj.
Thank you, Chairman. Thank you, Chairman.
Just to say to the participants, Sundaraj is one of the energetic personalities from IKN, and he's an upcoming star all the years after Matsudan, and he visited all the plants. He has seen all his coolers. He has benchmarked all the coolers. He has done a lot of research on the coolers, and we had a long interaction with Sundaraj, and I wish him all the best to his presentation.
Thank you, sir. Thank you, Murthy, sir. Good afternoon, dear all. The world is hoping that industrialists like us to make it greener and sustainable. Thanks to CII for organizing such and uniting us in the virtual world to share our experience and to keep the industry moving with zero carbon and greener tomorrow. Let us keep sailing towards each better day. This is Soundarraj from IK, and I am going to take you through the innovative and sustainable technology to save and sustain the energy for the future generation. Here we go with the session overview. In a bird's eye view, we are going to see the main criteria for zero carbon and how to counteract the challenges, the technology to counteract the challenges, trust and the yields from the technology. Main criteria for zero carbon. The challenges for zero carbon, that is an immediate measure that we have to look into this. To reduce the energy levels, identify the present energy levels, choose the target numbers, choose the suitable equipment, and maintain and sustain the results for a longer period of time. Energy consuming points and benchmarking by IKN. So if you look at the electrical energy, in the cooler fans drive and its auxiliaries, clinker crusher without HAR is more than 5 units in case of existing operating conditions in the industry. And thermal energy as a normalized cooler loss at 1.15 kg per kg clinker of a secondary year and tertiary year, the cooler losses are more than 100 kilocalories. Natural resources are used 24 hours, like water spray is used for 24 hours in case no WHR is present. And in case WHR is present, always with a compromising of the recuperation energy. If the WHR generation you want to produce, then recuperation is getting compromised. In the IKN, we have set a benchmark, like in the power consumption against more than 5 units, we have our lowest number in India operating at 3 units and highest number operating at 4.2. So there is an average difference of 1.5 to 2 units compared to the existing operating conditions in the other coolers in the industry. Whereas thermal energy also, similarly, we have 15 kilocalorie difference, and in the natural resources of water, we are using only 4 to 5 hours in a day, only during upset conditions. So WHRS, if you see the benchmarking number for a 10,000 TPD is increased in WHR potential by 1.5 megawatt compared to a non-recirculating cooler with a sustained cooler losses, standard normalized cooler losses of 90 kilocalorie. That means you have a cake and also you can eat it too. The challenges to reach the target numbers are deteriorated energy levels. It means the reduction of secondary air and tertiary air temperature over the period of time, increased vent air temperature, more clinker temperature, and increased power consumption of the cooling fans. So balancing WHR and recuperation is a very challenging task under present operating conditions. Sustaining the results cannot be measured in only one day, and it need to be sustained for the longer period of time. Production interruptions, like any stoppage due to the stalling of breakdowns, maintenance cost, and some of the coolers are demanding like capex for replacement of cooler within 3 to 5 years operations due to these challenges. We believe that a cooler should be operated for 15 to 20 years with a sustainable energy results. Why the challenges are, first of all, always the why is the essential step to identify towards a solution. So we'll go to the basics for some moment. For an ideal heat exchange inside the cooler, every clinker particle inside the bed should be surrounded by the cold air. The red color indicates here the heat in the clinker surface. To accomplish the ideal heat exchange, the air should exchange the heat of the clinker particle. In a real picture, if you assume 1 square feet of grate surface, how many clinker particles will be there? Maybe 10,000? In the vertical aerations are the limited holes and slots in a grate plate. Thus, a vertical aerations, there is a big gap between air to clinker contact. Anyone can understand from the picture that the effective cooling is not taking place in the cooler with vertical aeration. It means there is a compromise in the design stage, these first and second generation coolers. A process engineer says, I need a 10,000 holes to cover every clinker particle in the grate surface. But the mechanical engineer says it is not possible to drill 10,000 holes in the vertical grate, in the conventional grate plate. Ultimately, the cooler design goes with a compromise. So if you see this 3 pictures with the challenges of improper contact of air to clinker and ineffectual distribution from the static inlet and the negativity of the sandblasting effect in the vertical aeration, the effectiveness of the recuperation is challenged. If you look at into the graph, it is another interesting factor. You can see that cooler efficiency is dropping down over the period of time. Why? Increase in the gap, mixing of the clinker bed, wear and tear, and heat distortions. The original gaps could not be attained despite many efforts by mechanical team. Thanks to the mechanical team, at least they could try to improve up to some extent during every shutdown, but it is not sustaining. Again, it is deteriorating. So it could not reach the original number at any cost despite of many attempts. Then the sustainability of the results is challenged. So how to conquer these challenges? Some fundamentals to counteract the challenges from the IKN. KITS, Clinker Inlet Distribution System. IKN is built with the strong fundamentals. The static inlet concept is initially introduced by IKN and later all others followed. The Kondai effect, the strong horizontal air jets for the uniform aeration. LPS, linear pendulum suspension, and a simple drive which is located outside the grate surface. So in coming slides, I will briefly explain on these features of IKN. Horizontal aeration. A paradigm shift has happened in the clinker cooling technology. ICANN introduced a proven scientific method called Konda effect. When you pass the airflow through an inclined curved slot, it takes the horizontal path. By passing the cooling air parallel to the grate surface, you can reach every clinker particle. In this video, you can see in this grate technology, the air passes parallel to the grate surface and it simulates 10,000 holes. You cannot drill 10,000 holes, but by passing air parallel to the grate surface, you will be able to simulate 10,000 holes. The cooling air reaches every clinker particle and thus exchanging the heat maximum possible to the maximum effect. This is called Konda effect. And if you see the cross section of the IKN bed, which is made based on the Konda effect, there will be a layers of clinker, fines at the top and coarse at the bottom. This can be achieved with the Konda effect and partial fluidization. The advantage of such segregation is that the uniform heat up of air from bottom to the top when it passes the bed. The fines will have the most of the latent heat. When the air enters at 30 degree and is slowly getting heated up and it reaches at 1100 degrees or 1150 or 1200 degrees, whatever is possible, and it leaves the bed to the recuperation. This is what happening inside the clinker bed. The fines will be lifted to the top of the surface. Mainly the segregation of fines and cores takes place at the IKN kits clinker inlet distribution system itself. So this is the effectiveness of the recuperation is met with the help of IKN kits and Konda effect. So now the new challenges, clinker finer than ever or what now? Now the challenges are different in the operations. Clinker is getting finer and finer due to the fuel characteristics. To counteract this, IKN has come up with a new innovative kits, that is kits 4.0. What is the kits 4.0? With a strong scientific background of kits, IKN introduced to the cement industry kits 4.0 to counteract the challenging operating conditions due to AFR and high sulfur fuels and also very finer granulometry, which disturb the kiln process very often. So what are these 4.0? Hybrid aeration, that is chamber and direct aeration, dynamic transport segments inside the kits, and variable slope, and based on the proven effect of called Konda effect, which is new version is Konda wings. The center aeration in this kits 4.0 allows to create a valley instead of a hill in the center. In case of a coating pieces of too much of coating collapses happening, normally it will try to stay at the center of the cooler and it will divert the fines towards the both side and it will create a red river. With the help of this dedicated fan aerating in the center, we will be able to push this coating materials to the corner and so that the bed will become even. So the counteracting of this challenging operating conditions can be done with the help of this chamber aeration and the center aeration. And now, how to counteract the snowman? The snowman is also a daily affair due to the quality change and a lot of challenges in the quality preparations as well. Frequent air blaster usage will disturb the process and spoil the stratified layer which is being prepared in the static inlet. Continuous high pressure cold air jet is not good for the kiln and also it creates a lot of dust recirculation back to the cooler. So high pressure water jets, any UT pumps, is it a good idea? No, it isn't. And the safety aspect for the personal, grate surface and the refractory is not good. So what is an alternate? Yes, move the selected components of the static inlet to dislodge the cement. In the previous picture, you have seen the red color, which can be moved by a special drive elements underneath. So this is called inlet motion device, which is a part of the kits 4.0. In case of snowman formation, transport elements will be activated by the operator. No stoppages will be caused by the big snowman removal henceforth. So your snowman base can be moved out of the kits and you can continue the production without any interruption. So chamber aerations, which is helping to install these drive elements also. So the next is important thing is the finer clinker. How to handle the finer clinker? You can change the slope of the kits now. Earlier it was a fixed slope, 15 degree. Now you can change up to 10 degrees. So lower slope provides a better cover for the upper grade surface area, the lower risk of fines getting blown off. So always more material on the kits, you can give strong aeration and it will be quicker quenching and also better recuperation. So you can see this video before kits and after kits. After the kits, you can see the clear kiln with a less dust recirculation yellow line ends at exactly at the end of the static inlet. The orange line begins at the recuperation zone, and the black starts before the recuperation zone ends. So the yellow, orange, black is the IKN logo. If you turn it upside down, it is a German flag. So innovation is there even in the logo design of IKN. So the next is the linear pendulum suspension, the mobile structure. The mobile structure is supported on the pendulum suspension. So what is the advantage of this? The pendulum supports are placed in regular intervals, and which keeps the level of the mobile structure at the same position even after a long period of time. There is no sinking of mobile frame, and the thrust gaps above the grade surface will remain uniform for a longer period of time. This results in a uniform grade resistance in the upper grade, and hence uniform airflow across the width of cooler for a longer period of time. Hence, no deterioration of process results. So in this view, you can see that it has no roller and no bearings, and therefore no lubrication for this cooler. And the drive elements is completely located outside. So now, the design of the kits ensured that the highest recuperation and the pendulum suspension avoids deterioration of energy levels. Another important job is to conveying the stratified layer prepared at the kits till the end of the cooler without mixing. So the mixing and stratified layers will reduce the recuperation, and hence mixing should be avoided when you are conveying the clinker. So IKN has avoided the chances of mixing, and the stratified layer prepared in the kits will with the lesser movable parts and a special and simple technology of slow forward and quick backward motions. This slow forward and quick backward motions help to maintain the layer as such, and with the help of a hydraulic drive, it was achieved in the olden days. Now, with the latest technologies available, we are able to simplify the drive also as easily as possible so that your reliability of the cooler will be very high. So with the easily simulated, the slow forward and quick backward motions is being simulated with the geared motor and a VFD combinations. So that's this become a dynamic linear drive, and this is a very simple and this is the entire drive arrangement, and one VFD panel will be located within 100 meters of the building. So that is all. That's all cooler, and the advantages are that it is also able to drive slow forward and quick backward motions. So it is able to meet the requirement why this hydraulics drive has been used in the cooler. If you look at this picture, it can be twin drive, which is located outside the cooler. It depends on the width of the cooler and the production of the cooler. So all are well synchronized and everything is being taken care. And the DLD drive advantages are like no separate hydraulic room you need, no hydraulic piping, no hydraulic specialist, and no chains or sprocket, and lesser maintenance for the longer period of time. Now we have completed the technical parts, and I will take you through the case studies of Dalmiapuram IKN cooler. This Dalmiapuram IKN cooler, Dalmiapuram line to kiln was initially commissioned in 2006 with the second generation air beam technology cooler from the OEM. Due to the deteriorated performance of the cooler with age, the cooler upgrade was planned in the card to reach their goals. So IKN pendulum cooler was selected, who is known for sustainable results. So you have heard earlier, slow and steady will win the race. There is another side of this proverb. The fast and consistent will always will win the race. Here is the fascinating news on this happened in our incredible India. The complete engineering, supply and installation and commissioning happened during COVID pandemic time. So the facility of pre-assemblies really helped to make a quick assemblies, pre-assemblies. So if you look at this cooler, the complete internal elements and the casings have been erected in 18 days access to access. So with the Indian engineers only and with the digital support from IKN Germany through latest digital eye technology. So what about the results? The cooler was commissioned and the plant reached full production on time. The clinker was so cold so that it can be hand carried. It was a surprise to all the end users at the plant to touch the clinker in hand, and it is also a social media viral. So the objective of the cooler upgrade was easily met, and with the lower cooler losses and reduced clinker temperature as low as 40 plus ambient, and to reach that 40 plus ambient, IKN fans and drive and roll crusher consumed only 3.85 kilowatt hour per ton. So with this, they're able to save 40 kilocalories of heat consumption. So this is the happy team. With this happy team, we have further received further 7 coolers from the Dalmia including 2 latest generation dead layer coolers. So further case studies about the sustainable process results of Lafarge RS Mehta and Ultratech Cement Rajastri Line 4. So this Lafarge RS Mehta, now it is called Novaco RS Mehta. Bilaspur, it is located. This cooler was finalized in 2001 to replace a conventional cooler and installed in 2002. 2003, PG test was conducted. All the parameters achieved as listed below. In the last 20 years, we have visited many times this plant and made a joint audits. One of such recent audit is displayed here. In the last 20 years, still in the cooler is performing still in the guaranteed performance levels. And it is also new benchmark that 20 years of sustained results by IKN. Due to the calculated and perfect decision of Lafarge management, the owners are purely enjoying the without any second capex and also at the original energy levels. The cooler is
Mr. Sundarraj,
yes, sir.
time is running, and you have to present some new things than Lafarge RS Mehta, because some new.
Yeah, sir. I'm going ahead with the new things.
Just giving a guidance. Yeah.
Yeah, sure.
So that only 5 minutes is there.
Yeah, we have another further coolers running with the sustainable results more than 8 years, and this is one of the news about the Rajastri Cement Line 4. And this plant was initially designed and commissioned in 2013 with another OEM, as it is a brownfield line. So the process results are sustainable in this cooler also. In the PG test and also in the latest audit, if you see that process results are consistent, and for the last 8 years, not only this cooler, Ravan Line 2, and also Hirmi and any other Ultratech coolers, I can give example. In another groups also, we have a lot of examples, but due to running time constraints, I'm just passing it. So the main point is that the cooler results are sustainable based on the technology, and which is very much essential under present fuel conditions. So the further case studies are on the hot air recirculation system. So the WHR is an emerging trend in this industry. So everybody wants to have better recuperation, at the same time better WHR generations. So in this case, how you will achieve this, when the customer decides to replace the inefficient cooler for the improving recuperation, how to maintain the recuperation and WHR both. Ventless recirculation system, I want to have a cake and also I can eat it too. With this method, the additional heat available at stack between 100 to 120 degrees can be recirculated back to the cooling fans to increase the mid-air temperature. So in the case study, I'm going to share about an interesting fact on JK Nimbara Line 3 IKN cooler. They had a conventional cooler with a good WHRS generation. They have decided to improve the recuperation. To improve the recuperation and to reduce the clinker temperature, they wanted to go with a new efficient cooler. When they approached IKN, we have given a solution with the hot air recirculation to keep with the WHRS performance and without sacrificing the fuel consumption. So this is the JK Nimbara cooler, and in this you can see the hot air duct from the cooler stack at 120 degrees and recirculated to the selective cooling fans in the mid zone. How the cooler modification with HAR given a benefit to them. So if you look at this performance of WHRS, earlier with the second generation hybrid cooler, it was 6 megawatt, and after IKN with the hot air recirculation, it becomes 7.2. The efficiency improved by 14% and cooler losses by 35 kilocalories, and heat consumption has come down by 50 kilocalories with the help of burner modification also. So the production has gone up by 500 tons more. And the present kiln is now operating at 6,500 with the upgraded preheater and still with the same cooler without any additional capex on the cooler. So these are all some references of hot air recirculating IKN coolers, and most of them are from India, Ultratech Lines, Wonder Cement, Birla Corporations, and other cement groups, and Dalmia as well. So if you look at this picture with the mid-roll pressure, with a growing market share, IKN will be able to support between 750 TPD to 15,000 TPD coolers in the world with the successful running references. So recently we have received more than 12 coolers for our 8,000 TPD in the last 11 months. So the yield is that with so far 109 million tons per annum clinker in India being cooled by IKN, the savings are 20.1 megawatt power and 6,500 wagons of coal to the nation. So let our children have a greener tomorrow. And with all 1.09 billion tons per annum clinker being cooled by IKN globally, the reduction of CO2 is 9,000 tons per annum. So let us make a greener tomorrow and save for future generations. Thank you very much for your patience. And if you have any question, I'm ready to answer at the end of the session. Thank you, sir, Chairman.
Yeah. Thank you very much, Mrs. Sundarraj. Your closing slide is really good. That makes all of us to look at the green and the CO2 in calculation. ICANN is well known for the good cooler solutions. Industry acknowledges. I move to the next presentation. Enhancing overall system efficiency for next presentation is sustainability in cement industry. Dr. Sadasivam Suresh Kumar, Knowledge Lens. Welcome, Mr. Suresh Kumar. Are you able to listen to
Yes,
my
sir.
That's
Yeah,
good.
yeah.
Yeah.
Yeah, thank you. Sir. Thank you.
Mr. Sadasivam, we are just running out of time by about 5 to 10 minutes. But I try to give the entire time for you for about 20 minutes. Yeah. So because important is conveying the message to the audience, then the time, focus on what you wish to convey to the audience, and with your green solutions. I think Knowledge Lens is also one of the strong upcoming star, and we have listened to you in the last Cementech conferences, and in physical meet we met once in Hyderabad. But still the corona, we are safeguarding ourselves with virtual meeting. Probably by next meet, we'll go into the physical meets again. And I welcome to the platform of CI Green Cementech. And please start with your introduction and then continue the session, continue the presentation. Thank you very much.
Thank you, sir. Thank you, Murthy, sir. Thank you for CA for giving this opportunity on this session. I am Dr. Suresh Kumar. I am the doctorate in IIT Chennai. And I am in this field for last 25 years. So I was with the National Productivity Council 10 years. After that with the SGS as the national head 8 years. Now presently I am with the Knowledge Lens as the Chief Technical Director. So today's topic is the sustainability, mainly on the decarbonization. Yes, the previous speaker well explained about the technology, how we can able to reduce the CO2 emissions. Now the present scenario, because we are doing a lot of projects on carbon capture, storage and disposal, but most of the techniques are in the research phase. The actual, the capture, storage, disposal phase is not effective. But I can show you the recent one development has been made, and we are working with MOEF, and we are doing the CO2 capture by weathering using the olivine. And presently, how we can able to do sustainability strong in CO2 reduction. One is energy efficiency. The second one is the renewable energy, and the third will be the CO2 capture, storage, and disposal. So these three are the key things, but the CO2 capture storage is not at any proven method. In India, no project has been started. Everything is in the pilot scale or in the research phase. So generally, this is the breakup of how the cement industry intensive in energy, in both on manufacturing cost, on the electrical energy consumption, major energy consumption on kiln and cooler, cement mill and raw material. This is the major energy consumption, and we slowly reducing our energy efficient energy conservations by doing the efficient operations. If you can see in the below table. And majorly the sustainable improvements where we can able to focus. One is the cleaner production methods. The second one is the enhanced environmental performance through the very objective environmental indicators, improvement of the efficiency of our process, and the use of alternative fuels, which is already in the process, but still it has to be enhanced. And the production of blended and alternative cements are some issues, but that are also to be considered. Presently, the technologies need to be to give the significant improve the CO2 emission reduction, specifically in the Indian cement industry. One is utilization of advanced automation system in cement manufacture. We recently developed one of the things is the ball mill maintenance, preventive maintenance, how we can able to do it. Like that, we can able to do the maximum advanced automation system where we can able to reduce the operation cost as well as increasing the productivity. Use of nanotechnology in the cement production, that is another aspect which is upcoming, but it is on the process, it is going on. The third one is the alternative binding cement materials for reducing the CO2 emissions, fluidized bed advanced cement kiln systems, improving the burnability of the raw mix in fuel cell, that is again in the stage, and developing the national standards on the composite cells. Decarbonization, I can able to take, I am not going in detail on the decarbonization. I think the coming speakers are there in CCS, but I can say that there are two ways. One is operational advantages, technological innovation and new growth origins. The second way, which is to be the sustainable construction. Majorly the operational advantages, one is reduction by deploying more clinker substitutes, reducing energy intensity through better plant utilization and increasing the equipment effectiveness, recovering the waste heat recovery, and could also provide carbon-free electricity. And we can do the combining digital technology and more sustainable operations and incorporating the alternative fuels. Major potential technologies or sustainability initiatives on the carbon emissions. One is the energy efficiency, then high efficiency clinker coolers, and energy efficiency in the grinding systems, retrofit and the uniflow burner with advanced multi-channel burner, which is presently taking up on the flame properties. Multi-channel burner improve combustion efficiency and which can eliminate the flame impingement on the refractory. Energy efficiency improvement in the process fans. The right selection of VFD, if we are going for, then maximum energy savings we can able to observe during our exercises. Energy efficiency improvement in the auxiliary equipment in the cement manufacturing processes. The others are increased renewable energy use in the cement manufacturing, utilization of the advanced automation system in the cement manufacture. This is one of the way where we can able to maximum conserve the energy and improve the process efficiency. Adaptive predictive control system, online shell scanner and refractive management, online NOx control, so where you can able to do air to fuel ratio maintenance, online flame control, online free line control, flow measurement with advanced techniques, online measurement of kiln health, online energy management system for drivers and power generations, and remote monitoring and operator for split ionization plants. These are all the key areas where we can able to focus on the automations. It is 100% sure that we can able to increase our energy efficiency and improve our process efficiency, and the productivity will increase and increasing the thermal substitution rate. Generally, the advanced automation system in the cement kilns, one is the control and operation of the kiln system today is extremely this one, with the properties of input fuel and feed raw materials varying greatly, and with the product standards becoming increasingly stringent. So these two are the key factors where we have to focus or going for the advanced automation systems. Cement plant kiln operators today encounter such sudden variations. The dynamic control of the kiln is vital to achieve optimum results and lower manufacturing costs. So how we can able to address it? Effective advanced automation control systems can bring a substantial improvements in overall performance of our cement plant. Second is improving the vulnerability of raw mix by use of mineralizers, One is reaction efficiency side, compatibility with the given kiln feed, process adoption, physical form of mineralizers, and economical viability by using the mineralizations. So generally in CCS, I'm not going in detail, just I want to touch on the CCS. There are three ways. One is need to be captured. The second one is transport. And the third one is the disposal. Capturing is the major challenge specific to cement plant because our flue gas mainly on the kiln, that is the major CO2 emission sources. After capturing, you have other interference, other gases also like NOx, SOx. So in this, you have to go with either adsorption or absorption. So or you have to go for the different technologies to capture it. And the pure CO2 has to go into the storage, that is the compressed storage. Then the stored things has to go for the injection either in the marine disposal, majorly on the marine disposal, or the capture sequestration. So these are the normal options which are available: carbon capture, post combustion, pre combustion, and conversion. All are in the research phase. So nothing is on the plant scale so far. It has been made it. So everything is on the research scale, even not in the pilot scale. And separation technologies presently available are adsorption, absorption, membrane separation, and cryogenic distillation. This membrane and cryogenic distillation mostly for the hydrocarbons. So the one of the key technologies now it is coming into the play. Now it's going to start with the help of MOF in Gujarat by using the Vestra. So where it is using olivine as the mineral, which is available in India as well as in the other countries in a huge quantity. The olivine is the calcium magnesium silicate, is a mineral. So mostly where it will be, if you can see, the most of the CO2s are being absorbed by the sea. So the CO2 concentrations, whatever we are emitting into the atmosphere, that can be absorbed through the mineral on the seashore. So you can emit, say, take 5,000 tons of CO2, absorbed by the sequestration using using coastal environment by using the olivine, you can able to absorb by 10,000 tons. So you have the minus 2,000 tons of CO2 with you. There is a carbon credit mechanism, and this we are in the planning of the Kairan Vedanta in Rajahmundry plant. It is again on the initial phase of discussions with this test organizations. So this is one of the technique where the CO2 sequestrations can be done without having any further infrastructure expenses on this. Generally, how it will be, the atmospheric CO2 will be absorbed, forming as carbonic acid. So by adding the olein, magnesium silicate, so it will form as again as a calcium carbonate as the limestone bed. So your alkalinity of yours can bring it to the alkalinity stage, the healthy coastal environment using the olivine for CO2 sequestration. So one is the source, capture, storage, and disposal. Second, you can able to do the atmospheric absorption of CO2 by using olein in the coastal environments. These two are the options where we can able to use and do the CO2 sequestrations by enhanced weathering in the coastal environments by olivine methods. So thank you so much.
Thank you very much. Let us go with the next presentation, that is Mr. Debesh Dubey, enhancing overall system efficiency for decarbonization. Dr. Siddhasivam, your presentation was really good, particularly gone into CO2 sequestration. And yes, as you rightly said, that incubation stage. But just to inform that, Europe is already on the way towards
Yes.
CO2, and India doesn't take much time to implement them.
Yes.
This is the positive message.
Okay.
With which I move to the next presentation, Mr. Devesh Dubey. Devesh, can you listen?
Yeah, I'm able to listen, sir.
That's good. Yeah. So your time is now it is we are well on time. So 20 minutes for your presentation. Take your time and the messages and practical approaches in the plans, how to implement, how to go into the corporates, how to look into the things. Let us all focus on that, as your topic is very important, enhancing overall system efficiency for decarbonization. Just introduce yourself and please start.
Yeah. Thank you very much, Mr. Murthy, for the introduction. Hope I'm audible and clear, and my slides is visible.
Slides are not visible, but you are audible.
Okay, let me share once again. By the time I'll introduce myself, I am Devesh Dubey. I'm working as a segment manager for heavy industries in ABB India Limited for system drives. I take care for metal, cement, minerals, and mining as a segment manager. I have a huge experience in the heavy industry segment. I used to work, I'm working with ABB for last almost 12 years. Before that, I was with JSW Steel. Just let me know if my screen is still not visible or.
Not visible. Yeah, now it is going to. Yeah, now you are on the job. And just to say that ABB is also very, very important for all of us. And we all love ABB. And their research that is going towards this will definitely help us in moving forward. Yeah, continue, Mike.
Yeah. Thank you to Murthy sir, and I want to thank all the participants who are there from the cement industry. I want to thank CII also for giving ABB opportunity to present the solutions and the technical approach what we are adopting towards the customer for the topic of decarbonizations. And topic goes by itself, how ABB kind of technological company can help the cement plant in enhancing the system efficiency, which will end results to the decarbonization. So I'm going to touch a little bit upon how we are supporting the cement industry. The question and answer definitely we are going to take in the end. I don't know why slides are not moving.
Yeah, slides. Yeah, they are about. Yeah.
Okay. So just to brief upon and to be a little bit on the energy efficiency point of view only, the impact of ABB high efficiency motors and drives in India. We proudly say we have 12 terawatt of electrical energy saved in India by running with our efficient motor and drives, which is approximately equal to the energy consumption of 7 North Indian states. Moving forward, why we have taken this topic, why we have chosen the topic on the point of decarbonization. So first step towards the decarbonization, I feel it's the electrical energy. And what we want, we need a clean network. The network should be clean. The network should be efficient, should not be disturbance in the cement plants, and definitely help the production to maintain the very positive way. So to have a cleaner network, first point comes in this when we talk about electrical, it comes around the harmonics present in the system. So I'm going to touch upon a little bit on the harmonics and the solutions which are there for the mitigation techniques, how we can reduce the harmonics and make the electrical network clean. So first of all, let me say what we mean by harmonics. Whenever there is an ideal supply network, sinusoidal waveform, which is get distorted or by dips or transient voltage or frequency fluctuations, that cause to be a harmonics. And when it becomes a repetitive and predictability, non-supply sinusoidal voltage, current distortion and voltage distortion exists. That means our system is having harmonics distortion. There are certain techniques used which by meaning of which we can reduce the harmonics. I will definitely touch upon how it is going to touch how is correlating with the decarbonization. I will going to touch that also. So as we see, there are basic mitigation techniques of the harmonics for the electrical network. First point, I'll say we can reduce it. We have a reduction over it. There are separate different methods by which we can have a reduction. We can have introduction of reactors and chokes correctly sized with the inductance. We can have a diversions of the harmonics by using passive and active harmonic filters. We can have a cancellation effect by having 12 pulse, 18 pulse, or 24 pulse of converters or rectifiers with the special transformers. The best way, what we are going to talk today, we having a active rectifier or active converter, or we also say it as a ultra low harmonic drives. There are other techniques also which are less desirable solutions. Means you can have low capacitive VFDs with no impedance, but it will result in the low current distortion with a higher voltage distortion. Matrix style of variable frequency drives are also there, where we don't have a DC bus capacitors, which will be unable to achieve the full voltage to the motor and will have lower power factor. Both the solutions can provide, but it will have quite of robust big penalties in terms of robustness, power loss capabilities, and on our motor control capabilities. I'll just brief upon a little bit, touch upon the block diagram of the different technologies in the low voltage VFDs. When we talk, there are two type of VFDs which we see generally. We have a standard diode front-end drive system, and we can have an active front-end drive system. Let me take a pen. I'm sorry. When we talk about the basic difference, what is the basic difference in both the technologies? So any VFDs, if you consider, it will have three portions. First will be the rectifier, or it is also called as a converter. It will have a DC bus also, and then the inverters comes. Same is in the active front-end drives also. We will have rectifiers, we will have DC bus, then we will have inverters. The difference comes in the topology. Means whenever this rectifier section, when it is a diode base, it's a diode bit, it's become a diode front-end drive. When this rectifier or a converter is replaced with IGBT, the system becomes active front-end solution. What are the benefits? Inverter in both the case will be IGBT based. What is the benefit of having a low harmonic drive system or active front-end drive system? When you are using a diode front-end drive, the THID value, the total harmonic distortion, will be in the range of 35% at the input side with the choke. While when we are using an active front-end drive or a low harmonic drive, the THID, the total harmonic distortion, will come in the range of 3%, which is as per the standard set by IEEE 519 norms. Power factor in the diode front-end drives can be in the range of 0.90 to 95. While using active front-end drives, you have a power factor unity, that also starting from 25% of load. There is also a possibility that we can have a reactive power compensation from the low harmonic drives. Low harmonic drives or active front-end drives have a function which will have a voltage boost function inbuilt in it, which can have a maybe you can say we can have a voltage dip, still it can maintain the voltage output to the motor. It will have lower motor losses and higher system efficiency. Now, I will just touch upon how the harmonics is getting reduced by different techniques which are available in the market. When you talk about, say, we have a 6-pulse rectifier, then we have there is no line choke or nothing added over it. Then the harmonics level will be in the range of 72%. When you add a line choke or equivalent DC choke, the harmonics reduction happens. It can come down to 39%, 32%, 12% with the addition of line chokes. Another further, we can bring it to 12% when we have a 12-pulse rectifier with a 5% of impedance, means 3 winding transformers, we can bring down to 12%. Then if you have more, if you increase furthermore the number of pulses, it can come down to 5%. You can add a passive filter also, which will have the THD value of 9%. But the best solution, what I am proposing, what I am suggesting for the industry, is that we should have a IGBT supply unit or a low harmonic drive, which can bring down the total harmonic distortion up to 3%. So you can see the harmonic reduction which is happening in various technologies for reducing the harmonics. The best is 95.8%, which is there with IGBT supply unit. Moving forward, what are the benefits and the value propositions which as a customer, as an end customer from the cement plant are going to get? First point is the low harmonic content. As I told, it will be less than 3%, which is meeting the IEEE 519 norms, or I say it is better than that. You have a unity power factor at all the loads. Standard 6-pulse drive without input choke will have 0.7, 0.6 type of power factor, while with the low harmonic drive or active front-end drive, we will have unity power factor. There is another feature available in the active front-end drive, that it can give the reactive power control. That means when you have a linear and non-linear load both on the same bus, Still, we can have reactive power given by the drive to compensate the non-linear nodes. We can have a reduction in the transformer size up to 25% and immunity to the network variations. So this technology has a function which says that it can boost the voltage. It can sustain the voltage dip up to certain percentage. Improve the system efficiency. When you have a standard solution, diode-based drive and a passive filter solution, if you have a 400 volts as an input, the output voltage which goes to the motor may deteriorate by certain voltage, certain percentage. While if you remove the passive filter and use ABB or any active front-end drive, the motor voltage will be 100% since the drive itself is having a capability to boost the voltage. Efficiency point of view also, there is a 1% or 2% efficiency better because we are reducing the passive filter, which is additional equipment going into electrical network. Moving forward, now the point comes, how does this impacting, how does this helping to reduce the carbon emission? So if you see, any standard drive, when you have diode-based drive, it will have 40% THID, means it will have 16% of higher current losses. By avoiding, if we are using active front-end drives, it can come down to 3%. Increase generator and operational reliability. If we are using active front-end drives, it can increase the operational reliability in the weak networks. Reduction on the random disturbance if we are using active front-end drives. Reliable system without few circuit breaker stripping by using active front-end drives. We can have reduced wasted power from the distorted waveform. There is a reduced wasted power from the additional cooling fans, which is going to some additional equipment, like if you say there will be a chopper or there will be a, you can say, a resistor, which is for dissipating the power, that can be avoided. And we can avoid the penalties which is coming across due to the power factor, which is a huge loss to the cement industries. When power factor is lesser, electrical companies push penalties on that. That can be avoided. We can have 50% smaller generator. Transformer, as I told you, we can reduce the transformer size up to 20%. We can have a reduction in the cable size also up to 30%. We can have 10 to 30% reduction in the switchgear, circuit breaker, fuse sizing. We can have the optimized motor size that can go up to 30%, and there is no need of step-up transformer if there is a long cable distance kind of thing is there. So these are the points which is directly related to how we are reducing the carbon consumption by using this technology. Now I am just taking a case study how we have one of the customer, cement plant customer, got benefited using our low harmonic drives. We have given ROI calculations and how it is going to affect customer directly in terms of money. This is a case study for a 8.2 kilowatt system, 8.2 megawatt system. We will have a harmonic filter. We will have a power factor savings. When we talk about, this was the load which was distributed along the different kilowatts from 5.5 to 315, and various quantities were there. We have calculated the motor amps, and we have calculated the harmonic current, which will be driven by a diode front-end drive, and harmonic current which is driven by an active front-end drive. When you see a diode front-end drive harmonic factor, it will be 35%. As I explained you earlier, the DFE, diode front-end drive, will have a harmonics up to 35%. While if you are using active front-end drive, it can come down to 3.5% also. So when we calculated the difference between the harmonics current between these two technologies, we see that for the 8.2 megawatt load, we have approximately 4,400 amps of requirement which we need to reduce using a harmonic filters. So considering the approximate calculation for 500 amps per filter, we require 9 filters. When we take approximate price of per filter and we multiply it, we can see there will be a requirement of 13 million, which is going to be added as a capex when we buy a diode front-end drive. Also, there will be losses of filters 2%, and every year it will be multiplied. We have calculated for 5 years, it is coming around 15 million. So when you add total capex and opex cost for 5 years for having an additional harmonic filter in the system, this will be approximately 28 million. Similar with the power factor. When we see any diode front-end drive, the power factor, as I told you, will be in the range of 0.93. When we have active front-end power filter, active front-end drives, the power factor will be unity. We have calculated the differential total demand with the DFE and total demand with the AFE. For the same kilowatt of rating, 8.2 megawatt, we have calculated, and it comes to near about 3000 kVAR. We need a power factor compensation is needed. For that, we need to provide, considering per MVAR, if you consider 1.5 million, the total capex for the capacitor bank power factor, it is going to be 4.5 million. Plus there will be a approximate maintenance and the spare for that maintaining that filters. Plus if you calculate the running energy cost of the power, this power factors compensation equipments, it will be approximately, considering 1% of loss, 7 million. So that is also a huge cost coming across. It is 11 million. Additionally, what we are doing, we are going to insert 2 additional equipment in the electrical network, which is going to further reduce the efficiency of the network. We have to maintain that both the system, harmonic filters and power factor compensation equipments for for a whole 20-25 years of time. While if you are using active front-end drives, definitely these 2 equipments goes out from the system and your system become more effective and efficient. Now coming on the transformer size, I have calculated the transformer size also, saving on the transformer. If you calculate a total power and transformer size deviation factor for diode front-end drives 1.35 and active front-end 1.1. So size of the transformer which is required for a diode front-end drive will be approximately 15,000 kVA. When we size with AFE, active front-end drives, it will come down to 12,000 kVA. So saving, there will be direct saving of 3,000 MVA. 3,000 kVA, and when we consider the capex cost, it will be 4.6 million, and opex also with 1.5% of losses, it will come to approximately 10 million. So this is also a direct saving. So if you calculate the total capex and the opex cost by using an active front-end drive, there will be a huge saving, which as an end customer, as a cement plant user, you are going to get. This is a big ROI you can consider. This I've showed only for 5 years, but definitely any system which you are putting in the network, it will be minimum for 20-25 years. You will have a big saving in the capex, approximately 20-21 million, and in opex you will be huge saving of 32 million. So how it is getting related, how it is getting correlated to CO2. So if you see, we have done certain calculations with 60 kilowatt per hour of energy saving for 5 years will be equivalent to 1,700 metric ton of CO2 equivalent. Similarly, 30 kilowatt per hour of energy saving for 5 years will have 850 million ton of CO2 equivalent. This is how the energy is getting correlated with CO2, and with our using technology, what we are proposing, the CO2 directly get reduces. A little bit on the portfolio side, if you see, we have a complete range available in our portfolio. We have a different type of variant for different type of industries. If you see, we called as ACH 580, which is available in low harmonic functions, which is suitable for HVAC industry. When we talk about ACQ 580, it is suitable for water and cement. And for heavy industries like cement, metals, mining, we are having ACC 880, which goes from 4 to 5.6 megawatt. Here we have 4 to 350 kilowatt of range available in these industries because requirements are small. But for heavy industries, it goes generally ACS 880 drives, and all the low harmonic features are inbuilt as a default in these drives. Some of the value propositions which as an end customer directly you are going to get. First point, you will have a clean network, low harmonic content and unity power factor. Every day you will have saving. You will have immunity to the network disturbance, which it will also guarantee you the full motor voltage coming to the motor. You have optimized cost and space. Installation is very fast and easy. Maximum efficiency performance. It will improve the overall system efficiency 1 to 2%. Compatible with all type of motors. It can be easily integrated to any communication protocol. Now coming to the on the point of motors, how motor is going to support the decarbonization with the high efficiency motors. When you see the motor efficiency which has been set by as a standard, IEC standard, that is I1 to I5 up to 1000 kilowatt. When we have motor characterized in I1, I2 are low in efficiency. When we go to I3 and I4, it is definitely if we jump to I4 from I3, it will definitely have approximate specific energy losses less than 15%. Things are also available with I5, ultra premium efficiency are available nowadays. Now, if you talk about Indian market, Indian cement industry, which is running with I2 standards in India. Now things are moving thanks to cement industry, which is helping us to supply with I3 premium efficiency motors. Things have started in cement industry for demand of I3. Also in I4 in 2023, it will be minimum standard in Europe. I hope soon it will come in India also. When we talk about how it is going to impact on decarbonization, combination of low harmonic drives with the I4 motors, winding losses can get reduced up to 30%, which is definitely is going to improve your overall performance of the motor, overall performance of your process plants, and overall performance, it will impact direct the productivity of the plant. Now, if you talk about nowadays we see rewinding of the motors is a general phenomena in the steel industry, cement industry. Rewinding of the motors, one time if you rewind the motor, it will drop the efficiency by 2 to 4%. And every time you rewind it, the efficiency comes down. As an expert, we always advise to better to go replace the motor with higher efficiency of the motors. These are some critical type of efficiencies in low voltage which are available. We have 7.5 to 1000 kilowatt motor offering from India with IE4. We have IE5 offering from Finland up to 315 kilowatt. And we have IE5 plus offerings from USA, which is going up to 15 kilowatt. We can offer this to your industries very soon. Whenever you have a requirement, we are there to support you. Now coming to one more important topic, which we all are discussing, energy efficiency.
Time is running out, and please try to take care of the time.
Yeah, just 2 minutes. Just I am completing. So what is energy? Why energy efficiency movement? Energy efficiency movement is to bring all stakeholders together to innovate, act on energy efficient, regenerative, and adapting world. All the stakeholders has to work together and bring and to develop such a system which will have more energy efficiency. That is energy efficiency movement. We can together really make the difference on the energy efficiency movement. Who are the people who can contribute in this? The people who are doing the research, academic people who are doing the research and things. Technological companies such as ABB, we can provide you the solutions and the products which is having more efficiency. Public decision makers, government peoples who can participate with their decisions and boost us to develop some more technologies and give the solutions for energy efficiency. Business people like in cement industry, stalwarts in cement industry can contribute, looking towards the cost saving efforts and bringing down the energy efficiency, increasing the energy efficiency, bringing down the cost. Definitely investors is needed for all this, and private citizens which to use energy more efficiently. On sustainability, we are way ahead for ABB in India. Our all premises green are certified with green practice certificate for all the operating facilities. We are water neutral and positive operation across India. 80% of ABB portfolio have circulatory approach. 100% reliance on green power. We have zero waste to the landfill, and we are having fostering an inclusive workplace for the diversity. So that's it. That is my presentation. The floor is open for the question and answers, or we can take it in the end.
Yeah, we will take it to the end. Mr. Devesh, thank you very much.
Yeah.
Your 2 slides are very good, which says clearly the savings and the savings converted to CO2. Because the CO2 is very important, and conversion of technology into the CO2 calculations have become a daily job for us. So your message on IE4 is also very important. All electrical units, for that matter, I say that, a lot of work need to be done in every cement plant, because, the electrical, everybody is focusing on mechanical side, but the electrical side is sometimes ignored when I visit the plants. So I feel that, this is a very ABB with all electrical, because every energy is important, and every drop of kilowatt is important. This is, I move on to next presentation.
Thank you, sir.
Yeah. The next, thanks once again, Mr. Devesh. Yeah.
Thank you.
Keep the flag of ABB high all the time. Yeah.
Always, we are always at customer doorstep.
Yes, always. So the next presentation is SI Cement operations. I think this is new word for me. Sustainability and decarbonization in cement towards net zero carbon. Very important person is here, Mr. Chandrasekhara RS, Chief Digital Officer, India and Germany, Large Drives Applications, Siemens Limited. Mr. Chandrasekhara, please introduce yourself. You are a very coming from a very global perspective, and we welcome you to CII session on technologies for decarbonization in cement industry. Yeah.
Thank you very much for giving this opportunity to talk on CII forum, specifically on the green Cementech. So myself, I am Chandrasekhar. So I am working as Chief Digitalization Officer for Siemens LDA. in India. So I have worked across multiple countries in Siemens USA, in Germany, and now relocated to India and heading the business of large drives. I'm responsible for driving minerals, mining, cement, and other motor and drive businesses, all the digitalization aspects. I'm really honored and privileged to talk to you guys and be with you on the topic of sustainability and decarbonization. Yeah, so specifically talking about cement, where how the technologies can bring a revolution. Yeah, so what I am going to talk is something which is being not found very commonly in the industry, and it's completely new innovative solution which we have bought from Siemens. Hope my slides are clearly visible.
Yes, yes, they are
Perfect.
visible.
That note, I would move forward. When we talk oftenly about cement industry, we say that
You have
it's a
20 minutes time. Focus on the time also.
absolutely no problem, no problem. So I'll manage it within that. Yeah. So as you guys know that concrete is one of the most used substance in the whole world after the water. It makes one sense that we feel really proud of it, that we are part of manufacturing cements and so providing solutions for cement industries, which can develop and improve our infrastructure of the whole government. It could be buildings, um, roads, everything, right? So, and on the other side of the flaw side of that cement production is it also contributes to overall 8% of CO2 emission. So this is very, very crucial in the area of climate changes, what's happening right now. So we are looking at, and all the cement industries are also looking at how do you or we improve together on the sustainability aspects, right? So looking at this, we have come up with artificial intelligence based solutions which can help in reducing CO2, also to save a lot of fossil fuels. Yeah. On the other note, we should also take into account that last year around 4.4 million tons of cement was produced in 2021, and there is approximately 14% of hype in the requirement of cement demand. Yeah, so this becomes more important that we work on sustainability aspects. When we talk about technology in Industry 4.0, predominantly we focus on multiple areas like cloud computing, IoT, mobile technologies, AI and ML, and augmented reality, and so on. But today specifically, I'm going to talk about AI-based solution to enhance productivity and reduce CO2. Yeah, so how this comes all together and helps the customer. So as you know, one of the key important area where cement manufacturing becomes very tricky is the kiln area. Kiln is the heart of the cement manufacturing, and it's very, very difficult to control and stabilize this whole process and keep it in a very good range of temperatures. And because of the lot of dust involved in it, and because of a lot of temperature involved in it, it's very difficult to measure the accurate temperatures and control fuel rate or rotations of the speed or other parameters. Yeah, so this is where our AI-based solution comes into handy, where it can forecast the values for the operator. Yeah. So when we did the case study and noticed that only 13% of the time, both kiln feed and oxygen are in good condition. You can see this is called Shanky plot, where all other areas on the normal given conditions, it's only 13% of the time the industry is operating in a very good condition. It may astonish many of the cement manufacturers, okay, are we working only on 13% of good condition? But it also a good opportunity to know in a look at another way that you have close to 80% of opportunity to improve on and better perform. Yeah. So when we further drill down, we notice that only 10% of the time kiln feed, oxygen, and burning zone temperature, all of them are in a very desired range, and all other cases it is either up or on the lower side. Further analysis also stated to us when we analyze this data, only 6% of the time the four parameters are in a very good condition: kiln feed, oxygen, burning zone temperature, BET, and all of them. Why I'm talking about all these things? Because if you are working in this ideal condition, you have a chance of producing very good quality of cement with a very less consumption of fuel, especially fossil fuels, and less emission of CO2, right? So this is what we are targeting it. And how does it looks like when you are looking at alternative fuel, right? So every cement industry wants to go away from the fossil fuels, what they are burning from coal, and they use alternative fuels. But what happens with alternative fuels when you use is it results in a lot of fluctuation. You can see here RDF, coal supply, and centering zone temperature. So you can see the centering zone temperature ranging around 1100 to 1250 degrees. And when the RDF is introduced, you can see here it's predominantly stable, and the calorific values are a little bit varying here and there. But more important to notice that the operator behavior, right? When this is going like this, operator suddenly increases the fuel, what he is inducing, and sometimes he's reducing to bring down the temperature, right? So the sudden spikes and downs, this behavior itself will cause lot of wastage, yeah, or unburnt material of coal. Yeah, so this is what we have to stabilize. Now, what is our solution? How does our solution looks like, and how it helps to decarbonization with Siemens if you come across with the new technology? With our AI solution, now you can see the new line which is coming up here. So instead of getting very big spikes of increase of fuel or decrease of fuel, now the operator will get an upfront notification around 15 minutes or 30 minutes before what should be the set point ideal required for keeping the centering zone temperature within the limits. You can see that now the curve also has become very stable, and the fuel what he's infusing is also predominantly very stable, right? The exact amount required to keep the centering zone temperature up and running is what we are providing as a input, right? This is possible with our AI solution. What does it have capabilities? This platform, what we have brought down is called Cement Operations. So that's what our colleague was mentioning in the beginning. It's a completely new platform which is developed in last 4 years across Germany, India, and in multiple other regions. And it has capability to forecast for 15 minutes and 30 minutes, like a weather forecast. Like for key kiln parameters, you can forecast what will be the value in front of the operator in 15 minutes and 30 minutes. All traditional applications doesn't have these capabilities. All traditional automation solutions doesn't have this capability of forecasting with accuracy of 90%, 95%. What is the advantage of this forecasting of these key parameters to the operator, right? So operator has got fairly good amount of time to bring the outgoing, means out of control parameters into the range, and he can stabilize the whole process. By stabilizing the process, he's burning less fuel and less oxygen supply and less CO2 emission. Yeah, so it also gives early warning and indication. This was the story till the last year, but we did not stop there. We went ahead to the next stage, that is called set points generation. You can see from all the way from the control system, we got into the forecast till the last year, but this year we have also come up with a new solution, next enhancement solution called set point generation, which automatically sets the set points what is needed and sends it to the control system. Means the whole kiln operation as a control loop, you can operate without any human intervention in a very optimal condition. Yeah? So this has been tested and it's working in 2 of the pilot customers for more than 6 months now, and it's yielding very, very positive and promising results. Now, how does the savings looks like? So how does the CO2 reduction looks like, right? The amount of fuel what you burn less is the savings what you are going to get. Yeah. So let's have a quick look onto the analysis. Yeah. So the dotted line shows the upper and lower range for the centric zone, burning zone temperature here. And this line indicates the burning zone temperature. You can see that it was low in the beginning, around 1100 degrees, and it went all the way to 1400 degrees, and it started fluctuating there. Without our AI solution, right? Without our AI solution is the red color line. How does the fuel looks like? How the fuel rate looks like? You can see that there is a sudden spike in the fuel rate and increase, and it's coming down, which was not needed. And this was set by the operator, not intentionally, but he wanted to bring the temperature a little up into the normal range, but he did not know how much exact amount he wanted to bring in. Yeah? So this resulted in a spike of higher temperature reaching it out. Yeah, so that's what you can see. But if you have enabled our AI solution, the new set points, you can see it here, the blue color line. Yeah, so the much lower set points are set down, what is required by the system to keep this temperature within this range. So you can see the blue color line. The difference between the red color line and the blue color line is the amount of savings what you are going to achieve with this solution. And the numbers will speak by itself. How much savings we were able to do it for one line. So I am showcasing here. With every day, we were able to save up to 4 tons of coal per day per line in cement production. That means 7.2 metric tons of CO2 emission was reduced for a customer per line in the cement production. So this has been tested thoroughly. And we also have calculated it, how much will be the savings in terms of financial aspects. You can see 140,000, around 150,000 euros was saved, considering the 1 year horizon period. And this is only financial aspect, but the bigger aspect of what we are contributing to the nature is emission of CO2 is one which we are reducing and creating a sustainable future for the next generations to upcome. With that, I would like to also introduce one small portion of a solution of C-Cement operation. As I mentioned, this is a platform for the cement industry, which doesn't have only the capability of forecasting or setting the set point, but it also has the capability of detecting anomalies. Means any change that is happening in any part of this whole process, it detects upfront and tells in an average around 17 hours before, right? This cyclone is going to go jam, or your kiln is going to have so and so malfunctioning in 10 hours, 20 hours. So these type of anomaly detection is made available with our AI solution. So let's run through a quick case study. So one of the case study what we did with one of the customer worked out is we were able to identify an anomaly in preheater, right? So especially when the hot air is blowing from the bottom and the material is falling in the cyclones, right? The cyclones here, what you saw, the material is falling. The jam happens because of sometimes material is wet or so. We were able to identify this anomaly around 28 hours upfront. You can see the red dots, which indicates all the anomalies. And it finally happened. It turned out to be that the anomaly happened and the whole system was shut down, and it resulted in a lot of losses for them to bring it up. And the second aspect is that material is also get wasted, right? So because of improper burning and improper wastages. So this is the same what we are talking about. With this note, I would like to give a wind up a fair amount of chance for asking the questions. So you can get in touch with two guys, so from myself and Yun Zing from Germany. I think now we can take up some questions. We, I think, fairly have enough time now.
Yeah, any questions? Vaibhav, how do we take up questions, Vaibhav, later?
So right now there is no questions from participants side, sir.
Okay.
We'll just wait for 1 or 2 minutes, sir, to check if they have any questions. So in the meanwhile, sir, if you have any questions, you can please go ahead, sir.
Yeah. Once again, thank you very much, Mr. Chandrasekhar and Mr. Eugene, Head of Minerals Digitalization. And Siemens digital world is completely working, we all are aware, and part of CO2. Just to share some experiences of AI, this is expert systems, or AI we call, and definitely yes, the AI or expert systems are very important for our kilns and even mills also. And your new product that you are talking about, this cyclone prediction and jamming, this is very important. Only one correction I wish to convey to you is that, the material is not wet, that the material is jammed, just as a process guy I'm telling.
Yeah.
For the sake of, correcting.
Yes, absolutely.
Yeah, no problem. Important is, how the mathematics are taking the lead into the prediction and all, which is a favorite subject for all the engineers. And
yes.
We have to take on this particular note. And I must also appreciate all the, including you, that, everything is converted in. That means we are now living in CO2 every day. Every presentation is showing CO2. That says that, that whatever the seminars, platforms, or the forums that are in front of us are taking the big leap towards CO2. These are a few remarks from my side. and we wait for the audience to have all the questions on all the speakers. Then we will take up all of them together.
Absolutely.
Once again, I wish to thank Siemens and Chandrasekhar in particular from
Thank
your
you
side.
very much.
Yeah, Chandrasekhar. Yeah.
Sir, there is no question, sir, from participant side, sir.
Yes, yes, yes. Yeah. So what is the next step, Vaibhav?
Sir,
First of all, I wish to thank. We have good, excellent papers, Vaibhav. I wish to summarize the session. Meanwhile, we can look into the questions also.
yes, sir.
This session is once again very important afternoon session for CII. Going forward, I wish CII to conduct many more such opportunities for all of us to come under one umbrella, because it is very difficult to for every supplier to go to every plant and explain, that this is there, that is there, knock the doors and all that. I know the pain. So it is important that all the participants should take the benefit out of all these 4 presentations. So the first presentation from Sundar Raj clearly depicts what is the particularly on the heat savings, very important, on cooler replacements or even upgrades also. I wish to correct that upgrades are also equally important in existing coolers. They are coming up very fast. And the second one is the power saving. The most important that what Sundaraj has conveyed is that the entire cooler is about 4.3 to 4.5 kilowatt per ton. This is a very important message to all of us, because 1 kilowatt is a very high amount. So this is the maintenance and reliability. We are not talking about ICANN. Without ICANN is doing very good in the maintenance and reliability. But one message to ICANN I wish to give, that the plates are burning, and service is very important when the plates are burning, even with the latest some of the upgrades. And we conveyed that message to Mr. Madhu and Klaus also about those small issues of quality. Quality is very important while supplying the machines. This is the key message I wish to give to Sundar Raj. The second is knowledge lens. Knowledge lens is well captured with practical further knowledge lens to enter into cement industry is very important, because the person is coming with a great experience of National Pulpit Council, which is part of our India journey, and it captures a lot of his vision and thought process is very important for us. And we will see knowledge lens as part of cement plants in the coming days. We have both the presentations from both ABB as well as Siemens. Both are the real drivers in India or global also. And since 10 years, they are on CO2. They are on Europe. We all know the pressure, and sustainability is very important in Europe. The first region that takes this lead is Europe. So ABB and Siemens, though the solutions are expensive, but there is no other alternative. We have to think whether CO2 is important or whether investment is important, because that is to be seen by the management and all, and pressure is really going to come. So ABB, both the case studies are very good, because they are very good to implement right at project level, right at existing plants also. Siemens has come with expert system, but they can bring more into the portfolio, because this is artificial intelligence or predictive models. There are common applications in every process section, whether it is a raw mill or whether it is a coal mill or whether it is a cement mill. And this is the need of the hour, I wish to say, because plants, people, and scarcity, all everything knowledge, plus many things, many factors account for digitalization in this particular today context. And Yeah, this is summary of ABB and Siemens. I wish to convey a few messages from my side as chairman of such important session. Yeah. Hello. Hello. Yeah. I wish to convey. I wish to convey my final concluding remarks, Mr. Vaibhav. This is the message as a chairman of this such important session. The first thing I wish to convey is CO2 is a very big problem. Don't take it light. Time is running out and our speed should be faster than whatever that we released in the atmosphere. The reason is that if you look at 2026 and the commitments, and today we are already at 2022. So we know the picture, we know the scenarios. Here some pointers are, point number one is never compromise on technology. When I say that, whether it is existing cement plant or new cement plant, we should put our pen down by saying, I want the best. Because it is not your saying for you, but for the future generations and for the society as a whole. Cost should not come in the picture if our goal is CO2. Whether FLS or TKL or ThyssenKrupp or KHD or Loche or Pfeiffer or Cinema or TCDRI or ICANN or Fonts or ABB or Siemens. Everyone is ready to offer the latest. For example, we had a refractory seminar last 3 days and we observed a lot new products that came. We need to know them. It is the cement plant to buy all of them. This is the message that I wish to convey on the technology front. Technology is order of the day. Technology is very important. Coming to second point is operational efficiencies and plant performances. It goes into and penetrates into daily maintenance, daily MTBF, daily PRI, thermal, electrical energies. Every drop need to be closely checked at every duct in the cement plant. People are very important. We are in a digital world or global world on plants on mobiles, but consider them as only the tools. Never ignore a famous saying in Holcim, that is boots on ground. That is our favorite name in Holcim, boots on ground. That means we say machines will speak to careful listeners. Meaning is daily, weekly checklists, process measurements, including measurements at chimneys. Nobody climbs the chimneys today. Whatever the cooler balance we are doing artificial balance. We are not doing natural balance. We used to do natural balance in 1997 in Rajesh Cement Malkhed by climbing on the top of the chimney. This is very important. Measurements are important. The reason is we are focusing on daily thermal energy consumption and electrical energy consumption in the plant every day. There is a big saving that is going to come if people are very focused in every section of every cement plant, and all these small drops make a big ocean. Today, by selecting the best technologies, be what may, we are at a level of, we could reach a level with 30% AFR. We could reach with the best technologies. We did a research that we could come to roughly 425 kg CO2 per ton cement. Now, how do we become net zero after 425? This is an important question to the climate change panelists also, to the people also, because all the technologies, once we have put in place, it is at 425. So how to become zero? Maybe by alternate energies, that is solar energy, wind energy, definitely coming in place, which can reduce. We have to work out. The thing is alternate raw materials. To a great extent, it is possible, but we have to see the practical, really practical. But it is the order of the day going to be going forward. Coal. All European plants are at 100% alternate fuel. Why can't we be 100% AFR? It is possible, 100% possible. Technologies are available for 100% AFR. They are in place. Only thing is we have to take into account. But what will happen to the CO2 coming from calcium carbonate, which is a chemical reaction? This need to be seen as a technologies, as engineers going forward. We may say whatever that we can run to, let's say, some level. We need to see where we can run. After that, what we need to do is a question mark to all of us, but answers are available. They will be coming from rest of the world, and we need to take them into account. Here, CI, I wish to say CI, the message is, please push the government to make CO2 credits, to bring the CO2 credits, to bring the investments, whatever that are happening. Government also has equal responsibility to be part of the investments. Otherwise, the alternate approach is increase the price of the cement. When we are working for the society as a whole, why the bag of cement can't be increased in price? CO2 capture, put it, see the net cost, and take it into the consumer. That is a simple message that I wish to convey. Thank you very much, Mr. Vaibhav.
Thank you, sir. Thank you for your remarks and for chairing this session. We are also thankful to all the speakers for this session for their excellent presentation. Thank you, sir. With that, we close this session. The next session is going to start at 4:45. So we request all the participants to kindly join for the next session. Thank you, sir. Thank you very much.
Thank you.
Thank you.
Thank you very much.
Thank you.
Have a nice evening.
Sudevesh and
Thank you.
Sundar and all. Yeah.
Murthy, sir. Thank you, Murthy, sir.
Thank you, Murthy, sir.
Yeah. Thank you all. Yeah. Bye.
Thank you,
Thank you
Murthy.
all
Bye-bye.
participants. Have a nice evening.